Hi everyone, Assalamualaikum. In this video, we are going to discuss example 7 under integration by parts, right? Use integration by parts to solve integration of e to the power of negative 3x sine 2x plus 1 dx. Right now, let me look at the complete solution. In this question, we cannot evaluate using partial fraction because there is no fraction and not a polynomial function. We also cannot use trigonometric substitution because there is no radical containing square root of a squared minus x squared or square root of a squared plus x squared or square root of x squared minus a squared, right? Furthermore, we cannot use u substitution because there is no relationship between e to the power of negative 3x and sine 2x plus 1 in terms of derivative, right? And please note, despite the fact that this question is a product function, we cannot evaluate the integration using the product rule. It is because product rule can only be used in differentiation. Never use product rule to solve integration, right? The correct method to evaluate this question is using integration by parts, right? This question has both repeatable function, which is the exponential function and trigonometric function. So, we can use either tabular integral or integration by parts formula, right? First, I will discuss this question using tabular integral, right? When we use tabular integral under integration by parts, we need to use table with 3 columns. Okay, the first column should be sine. The second column is u and the third column is dv, right? In column u, we need to differentiate, while in column dv, we need to integrate, right? When we start to use integration by parts, we need to identify which function as u and which function as dv, right? In this case, e to the power of negative 3x is e, and sine 2x plus 1 is t, right? From Euclid rule, t come first, okay? So, t should be u, right? So, our u equals to sine 2x plus 1. And the other function, which is e, exponential function, becomes dv, okay? So, our dv equals to e to the power of negative 3x, right? Alright, then let's finish for column u first. So, we know when we need to start the row, right? So, from sine 2x plus 1. In column u, we need to differentiate, okay? So, when we differentiate sine 2x plus 1, okay, we have positive cos 2x plus 1, okay? 2 here, because we differentiate in bracket. When we differentiate in bracket, we get 2, so we put in front here. Okay? And after that, we differentiate cos 2x plus 1. We get negative sine 2x plus 1. 4 here because we still have constant 2 here. And then when we differentiate in bracket, we get 2 and then 2 times 2, so we get 4. And then when we differentiate cos, we get negative sine. Okay, that's why we get negative 4 sine 2x plus 1 after we differentiate to cos 2x plus 1. Alright? Alright, question and answer. How many rows should we differentiate? Okay. until the derivative of trigo give the same function as the given question. Okay, means that until the trigo function here give the same function from the given question. Okay, in this case, our trigo is sine. So, after we get back sine, so we can stop the rows. Okay, so we stop here. Okay, because from the given question, we have sine 2x plus 1. Okay, so we stop until the derivative get back the given function. Right? But if our u equals to algebraic function, we need to differentiate until the derivative gives 0. But when the given function is trigonometric function, we never get 0 when we differentiate. That's why we need to differentiate until we get back the trigo function that give in the given question. Right? And after that, we finish column sign. Okay? We begin with positive sign. Then we alternate with the sign. So we start from positive, negative, and positive. Okay? So our last row from here is row 3. Okay? So we stop until here. Okay? And after that, we integrate column dv. Okay? To integrate e to the power of negative 3x, we can refer this formula. A equals to constant. Okay, now our a equals to negative 3. So when we integrate e to the power of negative 3 dx, the answer equals to 1 over negative 3, which is equals to negative 1 over 3, and then e to the power of negative 3x plus c. Okay, so we put here. No need to write plus c because we still not finish our solution. Alright? And after that, we need to integrate negative 1 over 3 e to the power of negative 3x. So we get this. Okay? We move out constant negative 1 over 3, and then we have integration of negative 3x dx. So after we integrate, we still have constant negative 1 over 3 in front. And then when we integrate e to the power of negative 3x dx, we can refer from this formula. So we get negative 1 over 3 e to the power of negative 3x plus c. And after that, we can simplify negative 1 over 3 multiplied by negative 1 over 3. So that's why we get positive 1 over 9 here. Okay? So the last row here is 1 over 9 e to the power of negative 3x. Right? Right. After that, from the given question, integration of e to the power of negative 3x sine 2x plus 1 dx. Okay, we multiply this. So we get this. Okay, we have positive sign and then this function. So we have positive sign and then sine 2x plus 1 and then times negative 1 over 3 e to the power of negative 3x. Okay, and after that, we multiply this. Okay, we have minus sign and then we need to multiply this. Okay, so we have negative sign 2 cos 2x plus 1 and 1 over 9 e to the times 1 over 9 e to the power of negative 3x. Okay, and after that, we have plus sign here. Okay, for the last row, we need to multiply in horizontal. Right, and we need to put integration sign and dx. Right, and we multiply this function in a row. Okay, in horizontal. Alright, so we have positive and then we multiply this function and then we need to put integration sign. So we have positive sign and then negative 4 sine 2x plus 1 multiplied by 1 over 9 e to the power of negative 3x. And then we must put integration sign and dx. Right? So we get this. Okay. From the previous slide, we get this. Right? And after that, we need to simplify. Okay, so we get integration of e to the power of negative 3x sine 2x plus 1 dx equals to, we can put negative 1 over 3 e to the power of negative 3x in front here, and then sine 2x plus 1, and then minus 2 over 9, and then e to the power of negative 3x cos 2x plus 1, and then positive and negative, we get negative symbol. 4 times 1 over 9, so we get 4 over 9. We can move out constant from integration sign. So we put e to the power of negative 3x in front, and then sine 2x plus 1 dx. Right? And then from here, we need to integrate because we have integration symbol. But we no need to integrate this part because there is no integration symbol. Okay? So to integrate this, is it we still need integration by part? Okay? If we still use integration by part, we never finish our solution. Okay? Because we still repeat the same technique. Right? So in this case, from this part and this part, okay, you compare from this, okay, we have same term with left hand side. So we can move this term to left hand side. Okay, so after we move, so we get this integration of e to the power of negative 3x sine 2x plus 1 dx. From here, we have minus sign. After we move to left hand side, so we get positive 4 over 9 integration of e to the power of negative 3x sine 2x plus 1 dx. And then for right hand side, we have this, right? And from here, we have same term, and then we have constant 1 and plus 4 over 9. So we can simplify. So we get 1 plus 4 over 9 equals to 13 over 9. And then integration of e to the power of negative 3x sine 2x plus 1 dx. And then equals to constant negative 1 over 3 and constant negative 2 over 9. We can factorize. Okay, we can factorize negative 1 over 9, and then we have e to the power of negative 3x, and e to the power of negative 3x here, we can factorize here. So we get negative 1 over 9 e to the power of negative 3x, and then bracket. Okay, and after that, to get back negative 1 over 3, so we need to put constant 3 here, so that when we multiply negative 1 over 9 times 3, we get negative 3 over 9, which is equals to negative 1 over 3. Okay, and then sine 2x plus 1. After we move out negative sign, we need to put positive here, so that when we multiply, we get back negative sign. And then 2 here, because when we multiply negative 1 over 9 times positive 2, we get back negative 2 over 9. And then we have e to the power of negative 3x outside bracket. So no need to write e to the power of negative 3x here. So in bracket now, we have cos 2x plus 1. Okay. So this is after we factorize this. Okay. Alright, and then from here, we want to solve integration of e to the power of negative 3x sine 2x plus 1 dx. So we need to move times 13 over 9 to right hand side. And after we move, we can exchange numerator and denominator. So we get 9 over 13 times negative 1 over 9 e to the power of 3x bracket 3 sine 2x plus 1 plus 2 cos 2x plus 1, and then we can put plus c at the back after we finish all the integration. Alright, and from here we have multiplication operation here, so we can simplify 9 in numerator here and 9 in denominator here. So we get The final answer, integration of e to the power of negative 3x sine 2x plus 1 dx equals to, after we simplify, we get negative 1 over 13, e to the power of negative 3x times 3 sine 2x plus 1 plus 2 cos 2x plus 1 plus c. Okay, this is the final answer, right? Right, from the previous slide, after we integrate this question using tabular integral, we get this answer, right? So now we look back example 7, evaluate integration of e to the power of negative 3x sine 2x plus 1 dx, but this time we integrate using integration by part formula, okay, using this formula, okay? So from the given question here, e to the power of negative 3x is e, exponential function. And sine 2x plus 1 is t, trigonometric function. Okay? From Euler rule, t come first. Okay? So t should be u. Right? So whichever come first should be u. And we can write the function that equals to u in front. Okay, so we can rewrite. So we can write integration of sine 2x plus 1 times e to the power of 3x dx. Okay, so sine 2x plus 1 equals to u, and e to the power of negative 3x dx equals to dv. Okay, note dx always included in dv, right? And then we can rewrite integration of u dv. Okay. And under integration by part formula, integration of u dv equals to uv minus integration of v du. Okay. And then our u equals to sine 2x plus 1 and our dv equals to e to the power of negative 3x dx. Okay. Alright. From u, we need to differentiate to get du to substitute into this formula. And from dv, we need to integrate to find v to substitute into this formula. Right? So when we differentiate sine 2x plus 1, the answer equals to cos 2x plus 1, positive. And then we differentiate 2x plus 1 equals to 2. So we can put 2 in front here. Dx here come from du over dx. Okay, we move over dx from left hand side to right hand side, so we get multiply by dx. Alright, and then from dv we need to find v. We integrate using this formula. Okay, our a now equals to negative 3. So after we use this formula and we integrate, so we get negative 1 over 3 e to the power of negative 3x plus c. But no need to write plus c because we still not finish our solution, right? Right after that, we need to multiply u and v and multiply v and du, right? Then we get this, okay? We check one by one. Our u equals to sine 2x plus 1. V equals to negative 1 over 3 e to the power of negative 3x. And then we have minus sign and then we have integration sign. Our v equals to negative 1 over 3 e to the power of negative 3x. And then times du equals to 2 cos 2x plus 1 dx. Right? And from here, we simplify and we rearrange. So we get negative 1 over 3 e to the power of negative 3x. We put in front and then sine 2x plus 1. Negative times negative equals to positive. And 1 over 3 times 2 equals to 2 over 3. We can move out constant 2 over 3. And then we still have integration sign. E to the power of negative 3x cos 2x plus 1 dx. Right? From the previous slide, we get this. Okay. Okay, so we still have integration symbol here. Okay. So we need to integrate again using integration by part. Okay, so when we start to use integration by part, we need to identify the function as u and dv. So from here, e to the power of negative 3x equals to e exponential function, cos 2x plus 1 equals to t trigonometric function, and again from Euclid rule, t come first. Okay, so t should be u. Okay, right, and after that, we can rewrite, okay, the function as u in front, okay, so that we can compare with this formula. Yeah, so we put cos 2x plus 1, the function equals to u in front. Okay, cos 2x plus 1 equals to u, and e to the power of negative 3x dx equals to dv. Right? Note, dx always included in dv. Right? And then from here, we can rewrite integration of u dv. Okay, we still have the same function in front here. And after that, integration of u dv, we can write equals to uv minus integration of v du and put bracket. Okay, because we multiply with 2 over 3 in front here. Okay, and we still have this function. Okay, but this function we don't need to integrate because there is no integration symbol. Right? And then from here, our u equals to cos 2x plus 1 and dv equals to e to the power of negative 3x dx. Right? In column u, we need to differentiate. Okay? In dv, we need to integrate. Right? So when we differentiate u equals to cos 2x plus 1, we get negative sine 2x plus 1. Okay? And then we differentiate 2x plus 1, we get 2. We put in front. Dx here come from over dx from left hand side. We move to right hand side, so we get this. Okay? And then from dv, we need to find v. We need to integrate. Okay? Using this formula, after we integrate, we get negative 1 over 3 e to the power of negative 3x. But no need to put plus c because we still not finish our solution. Right? Right after that, we need to multiply u and v. Okay? And we multiply v and du. Right? So, we have this. Okay? Right, now we check one by one. Our u equals to cos 2x plus 1. V equals to negative 1 over 3 e to the power of negative 3x. We multiply. Okay? And then we have minus sign, and then we have integration sign. We replace v equals to negative 1 over 3 e to the power of negative 3x, and then times. We replace du equals to negative 2 sine 2x plus 1 dx. Right? From the previous slide, we get this. Right? And after that, we need to expand 2 over 3 inside bracket here. We expand 2 over 3 with this. Okay? We multiply 2 over 3 with this. Right? Right, so we have integration of negative 3x sine 2x plus 1 dx equals to, we still have negative 1 over 3 e to the power of negative 3x sine 2x plus 1. And then when we multiply 2 over 3 times negative 1 over 3, so we get minus 2 over 9. And then we rewrite e to the power of negative 3x in front, and then cos 2x plus 1. And then when we multiply 2 over 3 with this, we get negative times negative times negative times positive. So we get negative sign. Okay, negative times negative, positive. Positive times negative, negative. Negative times positive equals to negative. Okay, 2 over 3 times, we have 2 over 3 here. So 2 over 3 times 2 over 3 means 4 over 9. Okay, and then we can move out constant 4 over 9 from integration sign, and then we rearrange e to the power of negative 3x and sine times sine 2x plus 1 dx. Right? So after we simplify, we get this. Okay? Alright. At this point, it is similar to when we use tabular integral from the previous slide. Right? So we can refer the step from tabular integral. Okay? In tabular integral, in the previous slide, we get this. Okay? When we compare, left-hand side, we have integration of e to the power of negative 3x sine 2x plus 1 dx equals to negative 1 over 3 e to the power of negative 3x sine 2x plus 1 minus 2 over 9 e to the power of negative 3x cos 2x plus 1 minus 4 over 9 integration of e to the power of negative 3x sine 2x plus 1 dx. So at this point, we can refer from tabular integral and we get this step, right? So this is the final answer, right? Got it? Coming up next, one more example. We will discuss example 8, which is integration of cos ln 3x dx. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.